All right. Hello, everyone. Hope you had a good weekend. Just a few little announcements of what we're going to do today is finish up the last main article for this sort of second unit of the course. We'll do one more otherwise since we're getting late in the semester. I figured we just do some fun stuff a little bit. So we will read the panpsychism article a little bit later on. But this is the last main article, the last one you should need for the paper. My plan is that for Thursday, we're pretty much just going to do a giant overview of this second unit, and then sort of with an eye toward how to write a paper about this topic. So try to make some things sort of specific. My hope is you all will be the ones sort of leading the discussion in a lot of ways. So there'll be a lot of very direct questions, answers, that sort of thing. If not, it might be a comparatively short day. But then, yeah, that should get, my hope is that on Thursday, everyone will be in a really good position to write the paper after the end of that class. So that's the goal. Otherwise, we're going to do a short little unit. It's not even going to be a unit. We'll just basically have some fun little discussions for the remaining 2 weeks of the semester once we get done with this unit. We'll do some identity stuff, but we won't do it necessarily super seriously. Everything's taking way longer to do online. This is the case in all of my classes. They're pretty much all behind at this point. So, we'll just run with it, make it work as best we can, and try to learn some fun stuff sort of along the way. So that's my plans. Anyone have any questions or comments or thoughts on anything before we turn to finishing up the Bowden article? All right. One last little announcement of a sort. So for some people are doing their presentations by making videos. And what I'm going to do is I'm going to post those videos to the YouTube page for the course. So the first one was Fiona did it, and she submitted, and so I just uploaded it over the weekend. So yeah, go watch those videos when you get the chance. It won't be many. So far, only I think 3 students have told me they're planning on doing videos. One of them is up already, but yeah, when you get that opportunity, maybe go watch the videos, learn about some cool works of science fiction and some cool philosophy discussions about that science fiction. So last little bit of announcement. No one has so far told me they're planning on doing sort of presentations during the Zoom session itself, but that is indeed possible at least. Also remember, a lot of presentations are coming up in the last couple weeks of the semester. So if you haven't already done so, make sure you talk with me about the precise form you're going to do your presentation in and the content of your presentation so that that's all ready to go. Right. Any sort of questions or thoughts before we get started with today's material? All right, then let's get going. Let's just start by reviewing what we talked about last class. So we're reading Bowden's account of life, or more precisely, her account of why, as far as she's concerned, digital programs can't count as a life form. She's basing this on her account of metabolism. She's not exactly using Schrodinger, but she's in the same general tradition as Schrodinger is. And we're actually going to use Schrodinger a little bit today to help tidy up some of her concepts. A student, the first time I taught this article, a student raised the objection that her account seems to be circular, and the student was right. But I think Schrodinger can actually help her get out of the circle. Basically, it's not going to be clear that she can define she's going to try to define metabolism in terms of bodies, but it seems like she's going to define bodies in terms of metabolism. So it seems like she's not going anywhere. With that, we're going to use Schrodinger to try to give her a stronger sense of what she could mean by a body that help her break out of the circle. So this is still in the context of this sort of second big account of what it is to be a life form that we've seen, this one that's sort of loosely predicated upon kind of an entropic definition of life. All right. So her central claim is that a lot of the behaviors that we associate with life forms are basically functionalist in nature. What we mean by functionalist, we talked about this a lot last class. A functionalist concept is one that you can describe without really making any reference to the physical or chemical processes that are involved in the behavior. Right? So for example, when Badal is giving his concept of supple adaptation, he doesn't need to give any particular account of how that supple adaptation is actually occurring. It can be occurring through DNA mutation. It can be occurring through variation in code. It can be taking place through human economic systems. right? That's what we sort of mean by a functionalist concept. There's no particular material components or material background necessary to sort of define what he means by supple adaptation. And so as a result, because there's no particular physiochemical mechanisms that he's concerned with, Vidal entirely thinks digital things could in principle count as life forms because they can undergo supple adaptation, because the only definition of supple adaptation is, you know, something like Darwinian evolution, or being explicable in terms of the principles of Darwinian evolution. The precise mechanisms on a physical or chemical level of that don't really matter. We also talked about this last time in terms of reproduction, right? You can define reproduction without describing the specific mechanisms of reproduction. So Boden thinks most behaviors associated with life really are indeed functionalist concepts. They can be perfectly adequately described in this way. There's one big exception for it, though, and that is metabolism. Metabolism is explicitly describing a certain kind of physical-chemical system. And we're going to use Schrodinger's language to sort of characterize this. So to use Schrodinger's language, right, these are systems that are capable of auto-catalyzing as a result of DNA-like macromolecules, and as a result maintaining their entropic states for far longer than you would have expected them to. This is implicitly a description of physical-chemical systems. And so as a result, you can't sort of abstract away from the physical-chemical systems. Right? Her sense is that these functionalist definitions are all abstractions. To put it in this sort of language, you abstract entirely away from the matter in order to be able to just describe things in terms of form. And she thinks this works for most things, but it's not going to work with metabolism because metabolism is a particular kind of chemical interaction, a particular kind of chemical system. And so as a result of this, the purely sort of functionalist definitions that Vidal relies upon to call digital life life aren't going to work, and digital things just aren't going to metabolize in the right sense. They're not going to undergo the right kind of physical-chemical interactions or processes. So let's just pause there for a second. Got a little bit more to do, but where'd my, there we go. All right, so before we go into this, that was about the first half of last class. So any thoughts, questions about anything from that first half? Everyone's still good? All right. Second half then, this is the key, so that's the key thing she's going to need to justify, is this sort of claim that metabolism is not a functionalist concept. This is sort of the central claim in this article. So to justify it, she's gonna have to actually sort of just prove it. She can't just assert this. She needs to show that it's true. And so to do it, her strategy is going to be coming up with a couple of different functionalist definitions of metabolism. She comes up with two different functionalist definitions. One that she calls the weak metabolism, one she calls a stronger sense of metabolism. These are both going to be functionalist accounts, and what she's going to show is that both of those accounts aren't biologically useful. They're not the kind of account of metabolism that would be of any interest whatsoever to a biologist, so they're not the kind of accounts that are relevant for studying life forms. Then she's going to give the strongest sense of metabolism that's going to be a non-functionalist concept, and she's going to show this one is the one that biologists are concerned with, and it's this last one that digital things can't possibly do. Maybe androids could someday. They can't yet. Robots can't do this yet. But a digital thing in principle could never metabolize on the basis of this strong definition. So what we're going to need to work through is go from the weak definition to the stronger, and then to this strongest non-functionalist definition. Last class, we ended by talking about the weak one, the weak definition. So this is indeed a functionalist account. To metabolize is to be dependent upon energy for continued existence. And implicitly here, we're talking physical existence. So in principle, code satisfies this first definition, or a digital program would satisfy this first definition. A digital program, what is it? It's basically electrical charges stored in silicon. That's basically what computer code actually is. So if you cut off the power source of the computer, the electrical impulses sort of disappear, and so therefore the code would quote unquote die, right? Its physical existence, the existence of that code as a physical thing, depends upon the computer as a whole receiving energy. So digital code would work, digital life would be a candidate if this was a good definition of metabolism, but it's just not a good definition of metabolism. This is so broad that it covers basically everything. And I was thinking about it this morning. Every time my wife boils a pot of water to make some tea, that water is metabolizing, apparently. Because the water only boils if there's energy. If energy is added to it, if energy stops being added to it, the water stops boiling, right? The physical existence of the boiling water disappears, and you just have not boiling water. So this definition of metabolism is so broad that it's biologically useless, right? It covers almost everything. If you really want to get galaxy brain with it, I didn't mention this in class last time. If you really want to get galaxy brain with this, right? Like matter just is energy at the highest levels of description in terms of general relativity. So actually, all matter is dependent upon its own energy to continue to be the matter that it is. And so this definition literally covers everything. It's just not useful to the biologist. This one doesn't work straight away. She hasn't even really spent much time arguing with it. She thinks that any meaningful or useful sense of metabolism is going to have to talk about things like collecting energy, storing energy, spending energy to do various sorts of things. And just not, this definition doesn't include any of that. And so therefore it's just far too broad to help the biologist out. So that was review from last class. That's where we sort of ended. We ended by sort of discounting this very weak definition of metabolism. It's a very weak account of metabolism. Any last sort of questions, thoughts, comments about anything we covered last class? Everyone good? Is everyone good with this idea of a functionalist concept? That's sort of the key here, the key to this entire paper. We spent some time on it last time, but I want to make sure. Is everyone feeling reasonably confident about the idea of a functionalist account of something? All right. Then, oh, go ahead. Yep, you unmuted.
Hey, yeah. Just wanted like a quick summary of it, I guess. Like if you could put into like a sentence, what would be good to use in the paper?
So my one sentence summary of a functionalist of a functionalist definition would be: a functionalist definition is one that describes something only in terms of its form, not in terms of its matter.
All right, perfect. Thank you.
And so like here would be an example. If you said that a human being is a rational animal, if that's your definition of a human being, you've given a functionalist definition of a human being. Why? Because you haven't made any reference to the flesh and bone. You haven't made any reference to the heart, the brain, to how any of that stuff works, right? Your definition is just picking out sort of the formal characters of human beings and sort of abstracting away from the material accounts.
Okay, thank you.
All right, excellent. Good. Any other sort of thoughts, questions, any other thing you'd like to get clear on before turning to the new stuff? I guess not new stuff since you already read it, but the stuff we didn't get to last class anyway, the stuff that we're going to try to get caught up for. Go ahead, Angela. You should be unmuted.
Yeah, so I was wondering how exactly it relates to Schrodinger's idea of entropy, because like when I was reading her in one of the paragraphs, she was comparing like the organism as like a bundle of energy or something. So I was wondering like what like the most concise summary of the relationship between their opinions on it.
So yeah, what I'm going to suggest, and we haven't really gotten there yet, so this is a good question. This is sort of a good forward-pointing question. What I'm going to suggest is that we're going to need to use Schrodinger's account of metabolism to make sense of what she's saying, so that ultimately sort of Schrodinger will help clarify her own position and make her own position clearer. Okay. That her definition of metabolism is otherwise going to be kind of circular if we don't throw in the Schrodinger. And so what is it going to mean to have a body for her? A body is going to be one of Schrodinger's autocatalyzing systems. That if we give it that definition, then her account seems to work reasonably well.
Okay, so they're kind of on a similar page.
Yeah, they seem to be on the same general page to me. That's my rough sense. And no, maybe and this could be helpful too in terms of this sort of weak metabolism definition that we've got. Right, this is 100% nothing like what Schrodinger is describing. Right. There's all kinds of stuff that will continue to exist so long as energy is added to it. That's not interesting on any sort of physical level. The key thing for Schrodinger is that living things are able to maintain their entropic levels way longer than you would expect, just what they're made out of. But if you just continually add energy to stuff, it'll maintain its entropic levels indefinitely, right? I mean, entropy only drops. Entropy only drops in a closed system. If the system is open, you're constantly just giving it new energy. Then everything is going to be sort of entropically maintaining. The weird thing about living things, Schrodinger thinks, is the way that they maintain their entropy and how long they're able to do so, compared to the length of time the other things are able to do so on the basis of the amount of energy that sort of goes in and out. So I hope that's helpful.
Yeah, awesome. Thank you.
And we're going to say a lot more about it as we go today, too. So that's an excellent sort of forward-pointing question.
Okay, cool. Thanks.
Absolutely. Any other sort of initial thoughts or comments? All right. Then let's go to the second definition she gives of metabolism. This one she calls the stronger account. And it's still a functionalist account, but she thinks it's doing a better job of describing some of at least the formal properties of what's going on within metabolizing chemical systems. So it's still functional, but it's stronger because it's at least describing some of the formal properties of the chemical systems. Whereas the weak one didn't even do that. The weak one didn't even describe the formal properties of actually metabolizing chemical systems because of how vague it was and how abstract it was, how general it was. All right, so the stronger definition, metabolism involves either collecting or getting assigned energy that the system itself then utilizes to engage in various kinds of behaviors. Including possibly acquiring more energy. And the organism dies when it runs out of energy. So why is this functional? It's still a functionalist definition because we still haven't said anything about the specific, almost, if you want to put it this way, ways that the energy sort of gets assigned and used. Right, we're not describing any physicochemical processes or even describing necessarily a physical-chemical system even. Right, so it's still functional, but we are at least describing what's different, at least. She thinks this definition is stronger. It's at least pointing in the direction of what's unique to life forms. Right? So life, it's not just enough that you sort of get energy. It's not heating the pot, for example. The pot would have to, in some sense, utilize that energy to do something. right? And it just doesn't, right? The heat that I add when I turn on the stove top, right? It just causes the molecules in a very sort of direct sense to just start vibrating faster, so the water is boiling, right? That's not the water is not utilizing the energy to behave in any particular way, right? Whereas living things do, right? So when I eat food, what do those calories become? Well, those calories become countless things, right? My body uses some of the nutrients contained within the food to repair cellular damage. It uses the calories to trigger muscle contractions so that I can run to go then like chase a deer down and go get the deer, eat the deer to get more calories, right? So one of the behaviors is even getting more energy. What does a plant do when it photosynthesizes, right? It turns that energy and uses it in various sort of very concrete ways to cause growth and cellular maintenance within the plant. So we've got, we're pointing in this direction of these behaviors. Again, these sort of teleonomic behaviors. Right, sort of this Mayer account of these sort of goal-directed or program-directed behaviors, right? That's what the metabolizing energy sort of gets used for. So it's not just things that depend upon metabolizing energy, as we had with the weak account. Right? Now we've got that energy being used to, in some sense or another, generate these teleonomic behaviors that we see life forms engage within. All right. So how are we doing just with the rough structure of this definition? Is it making sense to people? So the thing that's basically getting added is these sort of teleonomic behaviors. That's the new thing, that's the addition that wasn't present in the first definition. Caleb, go ahead.
Yeah, so like her definition's kind of restricted to digital light, right? Like that's what she's engaging with.
That's what she's trying, at least that's the test case, I would say. It's not that it's restricted so much. She's intending these definitions to apply broadly. But she's testing to see, does digital life live up to these definitions?
Okay, because like, I'm just thinking, could there be an android with like a body that goes and does things to get more energy? You know,
sure.
Like would an android working at a coal plant to get more energy for itself count as something that's trying to metabolize? You know what I mean?
It probably wouldn't be a coal plant, I wouldn't think. Like, yeah. I don't imagine the android just like pouring coal into its boiler or something.
I don't know,
maybe
like
steampunk
electricity grid or something. Yeah.
Yeah, but yeah, that's exactly. So sure, yeah. I mean, I think on this definition that she's giving, an android would indeed satisfy it, or could indeed satisfy the definition.
Okay.
I actually can imagine a car even satisfying it. I mean, a car too, right? Like in this, the car doesn't actively collect the energy, but it does get assigned it, and that's one possibility she allows for. And then they use that energy to do stuff, right? To run the pistons in the motor, for example, right? Or to charge the battery, or yada, 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 right? And indeed, remember, when Mayer was giving this account of teleonomic behaviors, he thought they applied to human-directed artifacts too. Human-made things engaged in or had teleonomic behaviors just as much as as organisms did for Mayer, right? So yeah, I think androids in principle are fine. And someone's asking me about the replicants from Do Androids Dream of Electronic Sheep? Sure, I think they would do fine. If a car does, certainly the androids do, right? So I mean, again, this definition is a pretty broad definition of metabolizing, right? It's letting a lot of stuff into the club. Here's what's weird. It actually doesn't let digital life into the club, at least as it's currently been made. Digital things can't even satisfy this functionalist definition, at least as they currently exist. And here's why. The key thing in this sense of metabolism is that what is the thing that's doing this metabolizing? The organism is what metabolizes. And that's not anything weird. That's exactly what we should have expected, right? That's exactly what we sort of would have wanted to have been the case. But the code is not what actually metabolizes. And it doesn't get engaged in behaviors on the basis of the energy that gets assigned. What actually gets assigned the energy? The computer as a whole. Right. And then the computer uses that energy to run various bits of code, not just the code of the individual digital organisms. Each digital organism is running based on the operation of the computer, and the computer's running by taking energy and then assigning it to various teleonomic behaviors, fine. But the actual individual digital quote-unquote organisms, they don't get energy. The digital organism is literally just like a charge present within a silicon chip. The computer is the thing that assigned that charges to those particular silicon nodules, silicon switches, nodules, sort of silicon switches, let's say, right? It's not the digital organism itself that either gathers or gets assigned any energy on this model. So right away, we're trying to get a sense of what's so weird about digital life, why digital life itself is going to be the impossible one. Digital life, if it's life at all, it's parasitic upon something that's not alive in the slightest. No one's really tempted to just call a computer in general alive. Vidal wouldn't have been. But the code within that computer doesn't actually do anything with respect to energy in and of itself. The code doesn't say, give me some energy, computer. The computer gives the code energy, and then the code does various things, perhaps on the basis of the energy that gets assigned to it. So, but it's even weird to say that energy gets assigned to it, because it just is a little bit of energy within the computer. Like, that's sort of a way you could think about this. The code just is a sort of bit of energy or an activity engaged in by the computer system itself. The code doesn't have any energy activities of its own. In fact, the code is an energy activity of the computer. The computer uses the energy that it gets from being plugged into an outlet to make the code, right? And then to run and execute the code. So the code doesn't actually even satisfy this definition at all, because the code itself doesn't use energy to do anything. The computer uses energy to make the code do stuff. So the code is virtual, digital, right? It's a sort of a epiphenomenon, if you want to use a fancy philosophy term, that's sort of built over on top of the operation of the computer. So how are we doing? This is a bit of a tricky point. It's weird to think about but what's tricky about it is it's weird to think about what a computer program actually is. How are we doing? Does anyone have questions, thoughts, comments on this point? Because it's a tricky one. Again, the silence mean we're good or that we're not good. It can go either way. All right, well, let's keep going at least and see if we can continue. She thinks that in principle, though, we could design a program that could, in fact, satisfy the definition. In principle, and we don't design computers like this now, and it's not really clear why you ever would design a computer like this. It would be wildly inefficient. But in principle, anyway, it is possible that we could design some sort of computer system where each piece of code draws on its own independent energy source. Again, it's not clear why you would do that, but you could, I suppose. And if you did that, it would then satisfy the second definition of metabolism. Then each individual piece of code is sort of getting assigned its own unique energy that then gets used to engage in the various sorts of behaviors that the code engages within. Again, this is super weird. This isn't how we design code in general. But if we did somehow make a computer with this weird characteristic for some sense, you could maybe still say that it metabolizes based on this sort of stronger definition. All right. So again, just want to check in. How are we doing? Is this making, the key problem here is that the code itself doesn't get its own energy. It doesn't either collects it, then it doesn't get assigned it either, its own energy. It's the sort of result of the computer system as a whole doing stuff with its energy. If you could make it so that each piece of code somehow got its own energy, you maybe could change that up. It would maybe satisfy the second definition. Good questions, problems? All right, let's keep going, at least. We'll see if it makes it clearer or more confusing as we go. Bowden argues, okay, maybe if we design this weird sort of computer, maybe we could satisfy and make code satisfy the second definition, but this definition of metabolism still is useless to the biologist. And the reason why, she says, is that there is no unitary system. What she's calling a body. That engages in the metabolic activity. Here's a funny thing about computer code. So let's actually try to imagine we had some living computer code. What are we actually even saying when we say that? We are saying that a bunch of charges within silicon chips are alive. And guess what? Those charges might be spread all throughout the chip. They might not be even adjacent to each other on the chip. They might be all over the place, right? One little bit might be in RAM, one little bit might be in the hard drive. There's like activities in the processor relating to the execution of the code, right? And somehow all of those disparate things, right? There's no unitary physical system here. All of those disparate little bits of electrical charge are somehow a life form. And Bowden just thinks that's nuts. Like, that's not what biologists are studying when they're studying life forms or when they're studying metabolism. They're studying unified systems, right? Let's use Schrodinger to try to help with this, because this is where she starts getting potentially a little bit circular, but I think Schrodinger will help her be a little bit less circular here. Metabolism is supposed to explain why a living system maintains its entropic level. Right, beyond all expectations, beyond what you'd sort of expect it to be able to do based on the stuff that it's made of. And the weird thing here, we actually need a unitary physical system for this to make sense. We can't talk about the entropic level of randomly assigned little bits and pieces of stuff all over a room. You can only talk about entropy within a particular closed system that's at the minimum sort of like spatially continuous with itself. Right? That would be sort of a minimum requirement. That's what metabolism is sort of supposed to be explaining. That's why the biologists care about it. They care about the way in which the sort of closed system maintains itself in various sorts of ways. The digital code is not a closed system. You can't even measure the entropy of the code itself. You can only measure the entropy of the computer. The individual code just doesn't allow for that kind of analysis, for that kind of account. And so therefore, it's just not the kind of thing that biologists are looking at. It's just not the phenomenon that was trying to be explained by metabolizing. So this stronger definition doesn't actually address the phenomenon that it's supposed to address. And the reason it doesn't do this is because it's too broad. Right? And it's because it allows things without a body to metabolize, right? Non-continuous systems. And we've been interpreting body here even pretty broadly. We have a pretty loose definition of this. The sludge monsters that Kaufman was talking about, they still have bodies. They are still physically continuous, physically contained systems. Right? And that's enough, even though they don't have skin. They would be sort of just like a blob of goo or a blob of liquid or something. It still is contained within some sort of discrete physical location, so we can measure its entropy. You can't measure the entropy of computer code, so computer code, if it metabolizes, it's not like the kind of metabolism Schrodinger himself was talking about. And that's the key thing. Even if this is a fine definition of metabolism in some sense, this isn't the metabolism of the biologists. And so therefore, it's not a useful definition of metabolism to be applied to life forms. How are we doing here? Is this making sense? People okay? We got questions, we got thoughts, we got comments? Because if we're good here, we should be good for the rest of the paper. This is the hardest point to figure out why this sort of functionalist definition doesn't work. So if everyone's good here, we should be good to go pretty much for the rest of the way. Everything should follow pretty neatly from what we've just said. All right, then let's keep it going. So this leads her then to suggest the strongest definition of metabolism. This is a non-functionalist definition. Metabolism is, let me find it, I'll give it exactly as she puts it. Autonomous, bodily, remember body just means unitary physical system. Self-maintenance through specific physiochemical processes. or we could give the Schrodinger definition, self-entropy maintenance. We are describing specific physical chemical systems because entropy can only be described in specific physical chemical systems. That's why this is not a functionalist definition. We'd actually have to, if we were really to be fully adequate, talk about the specific material stuff that each thing we were saying metabolizing was doing to metabolize. What particular physical chemical system is it, and precisely how is it maintaining its entropic levels? All right. So how are we doing just with the definition? I think of this basically just as Schrodinger again. This is, I mean, we're adding that. She doesn't put in the Schrodinger part. She just basically puts this in terms of having a body. But I think that could be a little bit circular, like basically what is it to have a body to metabolize, and what is it to metabolize to have a body. But if we put this in entropic terms, I think it's really, really clear why this is not a functionalist definition. And you need a specific chemical system to be the kind of thing that can maintain its entropic level on this account. How are we doing? Is this definition okay? All right. Let's try to work out some of the implications of it that might be helpful. So what are we letting into the club on this? Okay, androids and robots as they currently exist don't do this. That was actually one of the key distinctions we drew. When we were describing the behavior of a car, the car, its entropy level is constantly increasing unless some mechanic comes in to repair it. Something outside the chemical system needs to sort of intervene in the chemical system, or else the entropy will just continually increase within androids and cars, right? And we see this in Star Trek with Data. Data has to undergo like physical repairs. If his hand breaks, it's not going to repair itself. Someone will need to come in there and repair it. Maybe even him, interestingly, but he'll have to take it off first. I have to remove his hand and then start working on it from the outside. It's not going to repair itself, and it's not part of a system that can repair itself. He can't repair damage to himself, whereas you can. When his system starts to overheat and parts need to be replaced, they're not going to be replaced by them repairing themselves. They're going to get replaced by Geordi sticking in a new chip or something. Right? It's something that happens from the outside. Similarly with a car, right? The mechanic is the one that's going to have to clean out the motor. The mechanic is the one that's going to have to clean out the fuel pump, right? I mean, the car is just not going to be able to do it on its own. The car's entropy will constantly be increasing unless it gets externally intervened. The living thing is the one that maintains its own level of entropy. It does it itself. And again, we're talking about the chemical system itself. The chemical system itself maintains its own entropy by stealing entropy or negative entropy from its environment. Right. But in principle, she thinks it's entirely possible that we could design artificial things that do it. And these systems could involve very novel kinds of chemistry. We don't know enough about Data really to know if he would satisfy this definition or not. It seems like it, the way Star Trek usually presents him, he wouldn't. But in principle, I could design a purely artificial thing that I have made that chemically metabolizes, right? That chemically maintains its own entropic levels, and maybe it's going to be made out of silicon. That's entirely possible. So it could be the Horta, it could evolve naturally, or it could maybe be hyper-evolved Data, maybe with nanomachines or some crazy, like who knows what. But it's possible that I could design some sort of chemical system that is artificial and still self-maintains itself. So in principle, at least, androids as they currently exist or robots as they currently exist don't satisfy this definition, but in principle, ones could be designed that could. In principle, even if not yet. We don't have the ability to do so yet. But a digital thing never could. In principle, because the digital thing, in principle, is not a closed chemical system. And so it doesn't have entropic levels of its own to maintain or fail to maintain. It's just not the right kind of thing to satisfy this definition of metabolism. And notice that Bowden's even going more generalized than Schrodinger, right? Schrodinger thought you needed very specific macromolecules to make this work. So like DNA-like macromolecules are needed to make systems that metabolize in the proper sense of the term. Bowden's not even assuming that. She's allowing for the possibility of novel chemistries that don't require these macromolecules. So it's more formal, you want to put it this way, it's more functionalist than Schrodinger was being, but it's not as functionalist as Vidal needs it to be for him to say a digital life actually is life. How are we doing here? Is this making sense? Is why digital life doesn't count? Are people feeling good about this? People feel like they understand it? Because probably, I'm guessing most of you are going to need to talk about this in your paper. So this is if you're not clear about it, this is an excellent chance for us to try to get clearer on it before you actually have to start writing. People good? All right. Then let's finish up the article, at least. So, all right. Last question that she considers, why should we say living things must metabolize? Why can't we just drop this? Why can't we just drop this condition? Why have this? Why have this in exclusive club? Why not just let digital life in? Bowden thinks that the reason for this is that while the concept of life is negotiable, it's not completely arbitrary. There's some phenomenon we are trying to describe out there into the world, she thinks. And we can modify our definition based on when new things are discovered about the phenomenon. Right? But it has to be with reference to the phenomenon itself. So one example of a time where she thinks it is possible something got added. She thinks the idea of Darwinian evolution has been added to the account of life forms. She directly references Badal in this juncture. What allowed this addition, right? Because 300 years ago, no one would have given anything like Darwinian evolution as a condition for life because no one even knew it existed. What allowed this addition is new discoveries about life. It's just an incredibly powerful explanatory principle, right? That's what allows us to add it into the account. Metabolism has also been an incredibly powerful explanatory principle. And so there's just no reason to drop it from the account of life. Or actually puts it, no non-arbitrary reason. I could do it just so that I can let my little pet programs in. But that's arbitrary, right? That's a circular reason, basically. My digital things are life forms, therefore metabolism must be a bad principle, right? I sort of presuppose the very solution I was trying to establish. Right? So this is an incredibly powerful explanatory principle, and she can't imagine a scenario that would cause us to drop it. She allows one possibility at the end, though she doesn't think it's going to happen. The only thing that she could possibly ever imagine causing us to challenge this is if we found maybe something like a sentient cloud. Or something like that, or maybe a sentient program, perhaps, could also. But even then, that's only if it turns out to be the case that only living things can be sentient. And there's no reason to think that. Otherwise, she can't even imagine what scenario would cause us to think that, in some sense, metabolism isn't a necessary condition for a life form. There's nothing we're going to discover that will challenge the usefulness of metabolism as this sort of explanatory principle. So we can't just drop metabolism to let our digital friends in. Right? There would have to be some independent reason, and she doesn't know what that would look like or what that could possibly be. All right. So how are we doing here? Does this all make sense? Caleb, go ahead. Let me unmute you.
Yeah. So, I just don't understand and maybe this is arbitrary in and of itself, but
Mhm.
like if something is conscious or a moral agent or sentient, why would we bar it from being living, only off of
Mhm.
the account of metabolism?
So here would be the argument anyway. So I'm not even saying I endorse it, but here would be the argument. The argument would be when we're doing life talk, we're doing biology talk, basically.
Yeah.
And the digital, the sentient cloud or whatever, which again, she doesn't even think it's possible, but even if you had a sentient cloud or something, right? Like, sure, maybe I have to let it into the sentient club, but that's a moral category. That's not a biological category, right? It doesn't mean that the biologist is going to have anything interesting or useful to say about this cloud. Okay?
I think
Or,
maybe
yeah, go ahead.
just the term living, I
Mm-hmm.
guess, is a strange concept for me. Like, obviously, it's a biological term, but when it comes to, like, if we were to see data,
Mm-hmm.
it would seem that, like, it would feel, I feel like he's alive. Does that make sense?
Sure.
And that's arbitrary too, but.
Well, yeah, I mean, so the concern would almost be this, right? Like, are you confusing two different questions?
Probably.
Because when you see data, yeah, he seems to be a moral person, right? That seems to be pretty hard to argue with. Again, we don't even know if things like data are actually possible, but let's assume Star Trek was real, right? Like, yeah, then when you see data, you're pretty clearly seen to be seeing a moral person, right? By all the normal standards, we gauge something to be a moral person. But he doesn't seem to be alive by the normal standards that we use for life. I mean, that's almost that Star Trek episode, that's almost what it was sort of like highlighting, right? Was that like Riker's presentation was basically like, this thing doesn't seem to be alive. Picard's was, this thing seems to be a moral person.
Yeah, that's a good point.
And so one risk, at least, is that the questions could get confused, right? I mean, I guess, if you want to get ethical with it, I guess you could run into the, like, people are prejudiced against digital things because they really don't seem to be life, but that's not the relevant question. What matters is, are they moral persons?
Yeah. Okay. I'm with it now.
Yeah, and I mean, almost just like another, do androids dream of electronic sheep? I mean, Dick just really seems to think that the replicants aren't life forms. They're fundamentally different in some important sense than the humans in the novel, that they're functionally identical to in a lot of cases, right? Like, in a lot of cases, you wouldn't even just be able to tell by looking, oh, that's a replicant, that's a human. But still, there are vital differences between the two, Dick seems to think. And it predominantly, in Dick's case, it doesn't seem to be so much metabolism. For Dick, it was actually, it was sort of more the kind of telenomic behaviors. Like Dick was just like, because these things weren't subject to evolutionary pressors, they just gave up when they were going to die. They're just like, oh, I'm trapped. Whereas living things don't do that, because millions upon millions of years of Darwinian pressure sort of like prevents that. So one way you could put, why does all of this matter? Because we want to distinguish questions of moral personhood from questions of life. If we want to do that, if we think that in principle those things could be treated as distinct, that would be one reason to think why this matters. But here's actually an opposite reason, Caleb. So let's just continue with this. You could go from the opposite perspective too. You could conclude, as a lot of philosophers have, that only living things can be sentient, at which point there's no point in looking for life and therefore for sentience in digital things. So we can sort of turn it on its head sort of as the opposite side. if, and either possibility is sort of open and it'll be valuable in either case. Bowden actually believes that this second one, right? If it's going to turn out that only living things are conscious, then if by definition a program can't be a living thing, by definition a program is not the sort of thing that can ever be conscious. Okay? So we can sort of go with either sort of track depending on what we think the relationship is between consciousness or life. And this question is an entirely separate one, one that we'll maybe try to touch on a little bit at the last couple of weeks of the semester. What's the relationship between life and consciousness, or life and identity? But here is at least one reason why keeping these concepts separate might be matter, so that we can actually ask this question seriously: what is the relationship between consciousness and life? So Caleb, was that helpful? Does that at least get at perhaps some of your concerns?
Yeah, that's good.
That's good? Okay. Good. I got a chat question too. So, yeah, there's also, and I think that's, you're right. So the chat question is, what if we flip number 2 on its head? If we found a conscious thing, then we also know we found a life form, right? And so maybe if we do indeed find a sentient cloud that can talk to us, like happens in Star Trek episodes, then we know that that cloud actually turns out that it had to be a life form. Surprisingly, unexpectedly, that's the sort of thing, Bowden can't imagine that being the case, but if that happened, maybe such a scenario would cause us to then be tempted to drop metabolism from our account. Then yeah, so I think that question is exactly right. Like, so either way of putting it on that second option, right? If there is this connection, it's still going to be helpful to separate the two ideas, because then we can sort of just track out how they relate, how they interact. Right? And this is indeed the only thing that she actually posits that could ever cause her to imagine dropping metabolism. She just doesn't think it's possible. She doesn't think it's going to be possible to find a sentient cloud or something, or a sentient program. Right? Because as far as she can tell, metabolism goes with life and life goes with consciousness. So I hope that was perhaps a little bit helpful of a discussion at the end there to help possibly clarify a little bit, maybe almost, I guess, the stakes of the discussion a little bit. Bowden has a little bit more to say specifically about Badal's proposal. I'm going to save that for Thursday's class. Because one of the things we're going to try to do is directly sort of compare and contrast those two accounts. I think, again, most of you, I'm guessing, for your papers are going to look at least those two. So that might be a helpful thing for us to save until tomorrow, spend some real time with it, remind ourselves exactly what it was Badal says, remind ourselves exactly what it is that Bowden says, how those things are related to what Mayer is saying, what Schrodinger is saying. Do big picture. That's a very big picture issue, in other words. So otherwise, I'm good for today. We're nearing the end anyway, only about 10 minutes left. So I'm happy to end it for today. If this Bowden stuff is making sense, if people don't have any additional questions on the article. So any last questions, thoughts about Bowden? Here we go, we got another question. Couldn't a sentient cloud have a complex metabolism that we don't just understand completely? It's a good question. What it would need to have, though, is some sort it would need to have some kind of enclosed body still. Again, body in perhaps a very broad sense, but it would need to be some kind of closed chemical system for the sentient cloud to have a kind of metabolism, right? So if we can come up with that, where in some weird sense the cloud is a closed system, then it could maybe have some kind of new unexpected form of metabolism, And Bowden's fine with it if we discover it. She's just imagining the cloud as something that's super diffuse, that's not really spatially contained in some sense. And that's why she's thinking it couldn't really ever metabolize. But if indeed we could find some way of figuring out an enclosed physical system for the cloud, then you're quite right. We could perhaps say that it does metabolize. Yeah. She doesn't think we'll ever be able to say that about the computer code. Go ahead. You should be unmuted. Oh, okay, maybe not. All right. Oh, okay. Sorry. So I hope that at least answers. That was probably just a thumbs up telling my answer to question. Okay, good. Sorry. All right, good. Any other last thoughts or questions for today? All right. Then let's end it here. On Thursday, we're going to do a huge overview. So try to put some advanced forethought into the paper. Maybe try to outline it or something in your own head. Figure out what stuff you don't understand fully, what stuff you think you need to get more clarified. Bring in lots of questions, bring in lots of comments. We'll do a very big picture overview of this unit on Thursday. Try to encapsulate a couple of very clear different positions for you to analyze in your paper. All right. No one has anything else? We'll end it here. All right. I'll stop the